Excellent paper by Daniel Archer here, Stellar Metamorphosis, Astron classification table. I'll read out some main points that Daniel brought about that's going to help me develop the theory even further as well. There's the table, I don't know if you can see it. The sun's being unruly at the moment. But I'll go ahead and read out a little bit of it, and some of the ideas in here which I think are spot on, and that I will have to expand to. If Daniel wants to expand on them, that would be cool as well. The abstract is stated, I present a classification table of astrons made possible due to the theory of stellar metamorphosis. In humanity's future observations of our galactic neighborhood, the expectation is that we will find many more older astrons around younger astrons. This is in accordance with GTSM. Due to this and that, in this theory, stars and planets are the same objects, just in different stages of evolution. We have to make a new classification table. This is so we can understand where to place new findings and to be able to make predictions in what stage a newly found astron is in. We would instantly be able to say a lot about what that newfound astron, based on other tenets of GTSM. Of course, the other tenets are going to be to be continued, things that need to be worked on in the future that will take a lot of time and brain energy, I guess you could say. But basically here, he has, at any point during stellar evolution, multiple phases of matter exist in that object to different degrees. That's very important. It isn't the object is all gas or all plasma or all solid material, and then it skips over like a giant step, and it instantly becomes all gas or all solids or all liquids. There are a mix of all the different phases of matter, but as a general rule of thumb, the classification scheme, as Daniel has here, is the population 1 is plasma, population 2 is gas, population 3 is liquid, and 4 is solid. And obviously that the solid stuff includes the asteroids and small moons, but the asteroids, a lot of them were not entire stars in of themselves, but are pieces of stars. So I'm not saying that, an asteroid is a star. It's just the core remains of one, and I'm sure Daniel knows that. But as astrons age, more and more phases are present at the same time to variable degrees. That's very important. Even on a very, very old star, just as Venus, which is basically a dead one, it has gaseous matter on the surface and a thick CO2 atmosphere. But as compared to Jupiter or Saturn, or any of the large gas giant exoplanets or evolving astrons, it pales in comparison in relation to those objects when it comes to gaseous material. There's a lot more gaseous material on younger objects. This is here. And another important point I saw here, temperature is mostly associated with plasmatic astrons, population 1, and to a lesser degree with gas giants. Yes, they have measurable temperatures, but once the plasmatic phase of an astron is over, assigning temperature becomes less meaningful. Very, very important. I'm glad you wrote that in there, Daniel. It is less important. As you'll see with the CoRot-7b, I'll explain it in a little bit. This is because an astron at that stage will have its temperature mostly determined by the type of its parent astron and the distance to this parent, to a lesser degree, its own internal heat, and the external or outer heat is gone. This is why from the late gas type astron the table indicates Na, not applicable. A little wordplay here. I'm sure Daniel, doesn't realize this is happening. He just took the word from the Wikipedia page. That's fine. I have no problem with it. We can correct this later. It's no sweat off my back. Everybody knows what's going on here. You actually understand the theory, so. But the fact is CoRot-7b here and the continuum, they have parent star. CoRot-7b is orbiting, it says here, a parent star. I don't know if you can see that. But it's very, very dangerous wording. Parent star sort of takes the idea that the star birthed the planet, and they both are orbiting each other. But Daniel already knows this. It's not like that. It isn't. The planet is a byproduct of star forming. The planet is a byproduct of star evolution itself. So clearly, they're two separate objects. It's not parent and son or daughter. It's host. So for future reference, we could better describe this theory in the objects. Instead of using the word parent, we could use the word host, because essentially it's the host. You know, like you go to a party and the host is there giving people drinks and, you know, letting them to their seats and, you know, being the host, for instance. But when you go to a party, you're introduced to the host. It doesn't mean that, you know, all of a sudden you're related to them. They're not the parent they're not your parent. That's a good way of remembering it. Think of a party when it comes to referring to planets. It's a big interplanetary party, and they're not related to each other just because they're in orbit around each other. For the same reasons why you don't go to a party and all of a sudden you're related to everybody just because you're there hanging out, having a good time. But that's a good way of memorizing it. Another point here, says here, also now with choosing only solar radius as a distance measurement, you can see that there are no gaps in this continuum. And that's in reference to the radius of the evolving Astron. He has tentative here, y is 1828, and that's fine. All this is tentative. This is a brand new theory. There's a lot to work out. There's going to be a lot of issues that come up. There's going to be a lot of things that are inconsistent, but we can correct those inconsistencies as we go along. Of course, my work and Daniel's work and, you know, Michael Z's work and everybody that's been working on it, Baz's work, we all have to come together and figure out how this all works. It's not a complete theory. It's still brand new, even though it's been a long ass time. It's essentially like 100-year-old theory. But onto CoRot-7b. I guess you could pronounce it CoRot. I don't know. But it's a object in between Earth and Neptune, more closer to Earth, as Daniel has in this paper here. And on the diagram here, CoRot-7b is pre-Earth, so mostly liquid, at 0.0186 to 0.0134, the radius of the sun. And the temperature scale is irrelevant, as you can see here. CoRot-7b would be more or less a pre-Earth. And it's good that he wrote that in there, because when you look at this, when you look at the Wikipedia page on characteristics, I'll go ahead and read this out to you. CoRot-7b has a maximum surface temperature between 1800 and 2600 Celsius. Due to the high temperature, it may be covered in lava. The composition and density of the planet, though weakly constrained, make CoRot-7b a probable rocky planet like Earth. It could belong to a class of planets that are thought to contain up to 40% water in the form of ice and or vapor, in addition to rock. However, the fact that it forms so close to its parent star may mean that it is depleted of volatiles, meaning light elements. A few inconsistencies here, and their corrections with stellar metamorphosis. CoRot-7b did not form around its parent star. Think of the party analogy. It was adopted by the host. It's an interplanetary party. CoRot-7b is way the hell older than its host, CoRot-7. And it says here, since it formed so close, that's an assumption. They don't know where the hell this thing even formed to begin with. All they have is this protoplanetary disk. So obviously, if it did form where it is, it would be depleted of volatiles, but it did not. Meaning, their previous statement, it's thought to contain up to 40% water in the form of ice and or vapor. Well, not only ice and vapor, but this thing's a damn ocean world, man. It's a pre-Earth. And Daniel has it in this diagram here, this table here. And there you go. It's probably a really steamy world in there with a thick water ocean. And of course, it's losing its thick ocean. And as it loses its thick ocean, CoRot-7b is also shrinking and cooling and moving into what I would like to say, according to this diagram, orange dwarf and then red dwarf stages. So the atmosphere loss is going to diminish considerably, and both of those objects are going to evolve together over many millions of years, unless they get ejected from a third body coming in and transferring angular momentum. But that being said, CoRot-7b should be interesting to look at. And Daniel, great job on this paper. I hope to see more papers in the future from you. If you have any other ideas, feel free to message me and ask me. Yeah, I guess that really sums it up. I'm gonna go ahead and post this to the bottom of this talk. And all right, y'all, take it easy.